velocity and speed. First, we will introduce you the definition of average velocity. Just now we said with the definition of 2 points A and B, we have the displacement vector r, delta r, or we can also say vector AB. And if we use the delta r the average velocity is defined as delta r over delta t. That means the average speed velocity from point A to point B, and the direction is along the displacement vector delta r. The magnitude is the magnitude of average velocity. And then we have average speed. V average equals delta S over delta T. And just now we said the magnitude of delta R does not equal to the average to the displacement to delta S. So we have this function. Average velocity does not to the average speed. The magnitude of average velocity does not to the average speed. And then we have instantaneous velocity. The definition of the instantaneous velocity is when delta t is very close to zero, the average speed equals the instantaneous velocity. We can also use dr over dt to represent the instantaneous velocity. Because instantaneous velocity is a vector, we can rewrite this vector into three components: Vx, Vy, and Vz. And for each component, it is a function with time t. And then we know that the direction of the instantaneous velocity is always tangent to the trajectory. And the magnitude can be calculated with this equation, root Vx squared and root Vy squared and Vz squared. And then we have instantaneous speed. Also, we can use the average speed to introduce the instantaneous speed. When delta t is very close to zero, we have the instantaneous speed, ds dt. Just now we said delta r, the magnitude of delta r does not to delta s. But But if the time t is very small, we can assume that dr is very close to ds. So we have this function. The magnitude of instantaneous velocity is equal to the instantaneous speed. After learning the definitions of velocity and speed, we have the definition of acceleration. Just now we said for every point A and B, we have a velocity, instantaneous velocity. The direction of the velocity is always tangent to the trajectory line. And from A to B, we have this very small difference, vector difference, delta V. And it can be written as Vt and the velocity and t and t delta t minus the velocity and t. So we have the average acceleration of A average equals delta V minus delta V over delta T. And in the same form, we also have the instantaneous acceleration A when delta T is very small. So we have the limit of delta V over delta T when delta T is very close to zero. And we can rewrite it as dV over dt. And just we said, V can be rewritten as dr over dt. So the acceleration is the second derivative of r over t. And in rectangular system, coordinate system, we have this function. The acceleration equals dv dt, and it equals dv over dt in every coordinate component. And the second derivative of the vector r and the second derivative of x, y, z in every component. So we have three. We can divide the acceleration into three components: ax, ay, and az. And every component can be rewritten like this. The calculation of velocity and acceleration are the fundamental part of current physics. You can calculate the velocity by the first uh, derivation of x, y, and z, and then you can calculate the second acceleration by the second derivative of x, y, and z. Okay, here are two kinds of problems in kinematics. The first kind is derivative from the position vector r. We can derivative it to get the velocity. And by derivative of velocity, we can get the acceleration. And in the other direction, from the acceleration, we can integrate it to get the velocity. And by integration of velocity, we can get the position vector. So we can know from this part, in order to learn physics well, you have to learn very well in calculus. Okay, you don't need to learn it very well, but you need to conquer some basic concepts of calculus to solve problems in physics. They are very close to each other. Okay, here's example 2. Deduce the following equation if particle move in straight line with constant velocity. Suppose t when t equals 0, v equals v0 I, x equals x0 I. I will give you 5 minutes to solve this problem. Just now, one student asked asked, uh, should we input those values on the three equations or just have to make vector equations? In fact, for this problem, we have to deduce the following equations. That means we need to prove the three equations with the given information. Okay, uh, the, from the given information, the particle move in straight line with constant acceleration. So, the acceleration is a constant and it is moving in a straight line. So the acceleration equals dv dt. dv equals a dt. And by doing the integration, we have the integration from v0 to v dv equals the integration from the, 0 to t a dt. So we have the first equation, v equals v0 and at. And in order to calculate the displacement or the distance moved, we need to do the integration of v. Because v equals dx dt, we have dx equals v dt. And by doing this integration from x0 to x dx equals 0 to t v dt. And then we have the second equation, s equals v x minus x 0 equals v0 t and 1 squared 1 over 2 a t squared. And for the third equation, because a equals dv dt equals dv dx dt, we have dx over dt equals v, right? We have v equals dx dt and a equals v dv dx. And from this equation, we have the integration from x0 to x a dx equals the integration of v0 to v dv. And we have the third equation. Okay, example 3. The motion of a particle is described by the function r equals 3 and 2t squared I and 2t squared minus 1 j. What kind of motion does it undergo? In order to solve this problem, first you need to write down the motion functions in each component. First, you need to write down the motion functions and solve the velocity and acceleration in each component. And then you should draw the you should solve the trajectory equation and draw the trajectory on the Cartesian system. Okay, I'll please find a pen and a paper to write down your answer. Okay, you need clue to solve it. Hmm. In fact, if you want to solve this problem, uh, the only thing you need is the functions we just learned. The first one is the velocity function. We said the velocity is the derivative of position vector dr dt. This is the first function, the first clue that you need. And then the acceleration is the acceleration is the derivative of velocity, and it is also the second derivative of position vector. Here are everything you need to solve this problem. So easy, right? Everything you need is previously taught. Okay, for this problem, we have the position vector r equals 3 and 2t squared I and 2t squared minus 1. The first part, 3 and 2t squared, is the x component of the position vector, and 2t squared minus 1 is the y component. So we can draw the trajectory equation. Y minus x equals minus 4, or y equals x minus 4. It is a straight line. So we can see that the particle is moving in a straight line with the velocity of 40 and 40. And the velocity is a variable velocity. And we can calculate the acceleration dv dt. It equals 4i and 4j. And it is constant acceleration. So the motion of the particle is described as a constant acceleration straight line motion. It is a straight line motion with variable velocity with a constant acceleration. Okay, here's example 4. The man on the bank drags the boat with constant velocity v. Try to find the velocity and acceleration of the boat when the distance between the boat and the bag is x. In order to solve this problem, we need to know the relationship between the boat and the man. The man is moving with a constant velocity, so the string uh, the string is moving with a constant velocity. And first, we need to set up coordinate x in the picture. then draw the position vector of the boat. Where should we draw the coordinate x? I think this is the best position because this position is fixed. And we can use r, the vector displacement vector r, to represent the boat. And we have r equals xi minus hj. H is a constant. And we have v equals dr dt. The velocity of the boat v equals dr dt. And we can see h is a constant, so v equals dx dt. And we can rewrite r, the magnitude of r, with root x squared and h squared. So v can be rewritten as what dx dt. And we have the here we have lost one important equation. Here we have the magnitude of r equals what? Root x squared and h squared, right? And we have the relationship between x and r equals x over root x squared and h squared. So we can rewrite dx as root x squared and h squared over x dr. So we get this function v equals minus root x squared and h squared over x, the magnitude of constant velocity v. And the acceleration can be rewritten as dv dt equals v squared h squared over x called cube. Okay, today our class is over, and after class, I will give you this PowerPoint for you to review. In the next class, uh, we will see the following examples and learn more about how to solve these problems. If you have time, I hope before next class you can take a brief preview of what we will learn, so you can understand it better. Okay, class over.